The guitar, an eloquent, beautiful, and euphonious instrument utilized in almost every musical style, made in many forms such as classical, acoustic, and electric. The guitar is the quintessential instrument in today's pop, rock, and acoustic music. Although not as popular in the broad range of rock, the classical guitar is employed in the fields of flamenco and classical music immensely.
Before we dip into the physics of classical guitar, let's look at some of the background information of the instrument. The classical guitar varies from the acoustic and electric in many various ways besides the sound. While electric and acoustic guitars have steel strings, classical guitars have nylon strings that create an easier and softer sound, along with advocating finger picking like the show. An advantage of the nylon strings is that because of the low tension, the entire neck of the guitar can be made out of wood, making it more aesthetically pleasing. Also, the classical guitar is smaller than every other style of guitar, making only 12 frets easily accessible, instead of 14 on an acoustical or electric. The neck of a classical guitar is also much wider than it is on an acoustical electric, facilitating finger picking. But a disadvantage of this is that it makes it harder for thumb chords, such as this G thumb chord. The guitar has 6 strings normally, starting with the E string and ending with a 2-octave higher E string. The guitar was originally made to be played without accompaniment and contains over 3 octaves of piano notes. Starting with the 6th string, notes range from the 2nd octave E, or E2, to the 1st string's 12th fret E5, so 5th octave E, and even higher. Every note has a different frequency, with the total frequency range of a classical guitar being from 82.41 Hz to 987.77 Hz on the 19th fret of the 1st string. Another key note about any guitar's frequency is that the octave doubles the frequency. Say an octave A2, the frequency being at 110 Hz. Playing the next octave would be an octave A3, and then the frequency will be 220 Hz. The sound hole in a guitar gives the guitar projection, although guitars will still make noise with a solid body. The reason why there are sound holes in a classical guitar is to increase resonance, especially in the lower frequency notes. The guitar's body also affects the sound of the guitar. The type of wood that a classical guitar is crafted out of changes the brightness of the tone of the guitar. The front of the body is usually made out of a softwood, such as spruce, while the back of the guitar is made out of much harder wood, such as birch or mahogany, equaling out the tone to a full but not extremely bright tone. The string itself also affects how well the guitar sounds. The string is most pliable in the center of the guitar, near the sound hole, and looser as you get closer to the nut, which is right here. But as you get farther away from the sound hole to the other side and closer towards the end of the bridge, the sound becomes a hard and brassy sounding, almost like a banjo.
So at my show on Monday, I was hoping someday you'd be on your way to better things. It's not about your makeup or how you try to shape up